All right, today we're diving into something that sounds, well, straight out of a cosmic cookbook. We're talking about how to make actual stardust right here in a lab.
I mean, really think about that for a second. What if you could hold a piece of a star? Not just any star, but one that died billions of years ago, long before our sun even existed. It's a pretty wild thought, right?
Well, here's the thing. It's not just some cool sci-fi idea. It's real. Scientists find this stuff all the time, tucked away inside meteorites that have fallen to Earth. They're like these tiny, ancient fossils, little messengers from across deep time and space. So the official term for this stuff is pre-solar grains. And the name says it all, right? They're grains that existed pre-solar, before our own sun. They're basically time capsules from other solar systems. And these little grains, they're the heroes of our story today because they give us this incredible direct window into how other stars live and die.
Okay, so we're talking about stardust found on Earth. But it turns out not all stardust is the same. Scientists found one very specific kind of cosmic dust, and it presented this massive puzzle. I mean, it just didn't make any sense, and it had researchers scratching their heads for a long, long time. So what was this peculiar particle? Get this. It's called a carbon onion. Yep, an onion. These little things are born in the skies of ancient dying stars, what we call AGB stars. And they get their name because, well, they're structured just like an onion. They're these tiny spheres with a core right in the middle, and then all these layers wrapped around it.
So let's talk about the puzzle of that graphene core. Because the problem wasn't really the whole onion. It was what was hiding right at the center. The outer layers, the rim, scientists pretty much had that figured out. But the core was a total mystery. It seemed to break all the rules we thought we knew about how carbon is supposed to act. And this is where it gets really weird. The outer layers, that rim, it's made of graphite. Think of it like a perfectly stacked pile of paper where all the atoms are in these neat, orderly sheets, totally predictable. But the core? Whoa, that's the mystery. It's made of what's called unlayered graphene. Instead of neat sheets, it's like someone took all that paper and just scrunched it up into a messy, jumbled ball. It's totally disordered. And nobody could figure out how nature could even make something like that.
And this was the big problem. Our best and most powerful computer simulations, they just couldn't do it. Scientists tried everything, modeling the extreme conditions around these stars, but no matter what they did, the simulations could never, ever replicate that messy, unlayered graphene structure they were seeing in the real-deal pre-solar onions.
So what do you do when your most powerful computers can't crack the puzzle? Well, you think differently. You build a star in an oven. Seriously. A team of scientists decided, okay, if the simulations won't work, let's just try to build it for real. They set out to create a physical experiment that could mimic the environment of a dying star.
And they had this really clever hypothesis. They called it the supercooled droplet idea. The thinking went like this. What if the carbon doesn't form slowly like frost on a window? What if it first becomes a tiny liquid droplet? And then, and this is the key, what if that droplet cools down so fast that it basically flash freezes? The idea was that this super rapid cooling wouldn't give the atoms enough time to line up neatly. They'd get trapped in that jumbled, messy state, exactly what they were seeing in the core.
Now, to pull this off, they needed some serious heat. I mean, a lot of heat. We're talking about temperatures over 3,200 Kelvin. Just to give you an idea of how hot that is, it's way, way hotter than sublimating carbon. It's the kind of insane temperature you need to turn solid carbon into a vapor, which was the very first step in their cosmic recipe. All right, so let's get into creating these carbon onions. How exactly do you go about building a tiny oven to forge stardust? It sounds incredibly complex, but the setup they came up with was actually kind of elegant in its simplicity. And yet, it was powerful enough to get the job done.
So, here's the experimental recipe. Step 1, you take this tiny hollow graphite oven, just about 6 millimeters across, and you heat it up inside a vacuum. Step 2, you get it so incredibly hot that the walls of the oven itself start to vaporize, creating this cloud of carbon vapor inside. Step 3, that vapor cools down, forming those liquid droplets we talked about, which then supercool and solidify. And finally, step 4, you just collect the brand new particles to see what you've made. So, after all that, building a miniature star in a lab, did it actually work? This was the big moment. Did they really manage to cook up the same kind of stardust that we find in meteorites? Time to decode the cosmic recipe. And the answer was absolutely. A perfect match. When they looked at what they made, it wasn't just any old carbon dust. They had actually done it. They had created those elusive carbon onions, complete with the core and the rim. And the numbers checked out perfectly. Looking at the composition of their lab-grown onions, they found that about 60% of the particle was that mysterious unlayered graphite core, and the other 40% was the graphitic rim. The structure wasn't just similar, it was a dead ringer. But they needed absolute proof, the real smoking gun, as they say. This came from an analysis technique called electron diffraction. You can think of it like taking an atomic fingerprint of a material. So when they zapped the rim, they got the pattern they expected, the fingerprint for normal layered graphites. But the core gave back a totally unique pattern with these weird high-frequency tails. And that was the unmistakable, definitive signature of unlayered graphene. Case closed. Just let that sink in for a moment. For the first time ever, scientists had made stardust with that mysterious unlayered core right here in a lab. They had solved a puzzle that had been baffling them for decades. And look, this is so much bigger than just making a cool particle. The researchers themselves put it best. Their observations confirmed that this process works. Condensing carbon vapor really can create these core rim graphite onions. And that helps us interpret what's actually happening out there in space. It lets us understand the specific conditions that lead to this kind of crystallization around real stars. So, if we can decode the recipe for stardust right here on Earth, what does that mean? It just makes you wonder, what other cosmic secrets are out there, not hidden billions of miles away, but just waiting to be unlocked in our own labs? What else can we figure out right here at home?